And welcome back, students, to our final thing on C, and that is of pointers. Now, pointers is a concept that's a little new to us in terms of what is a pointer. All right, but we kind of know about them inadvertently because really what a pointer is a way to point to the memory address in the computer. So that's kind of like the short end of it. There's a little more nuance, but we look at something like Java. Java doesn't worry about. It's like, hey, there's memory. I can use it. Great. I can garbage collect it later. C, on the other hand, a little more fickle. So what we're going to look at here, and this, I'm going to leave this up here for you to really dig into the meats and potatoes of the content here, is when you're working with a program. All right. So, for example, right here, this is something that we've seen before. If I don't properly, format something correctly for an output, I get this like code-looking thing. All right. So, for example, you see address of the variable, and we get this right here because normally when we do printf, we don't put the ampersand in front of that. We simply just would say the name of it. Well, when you put the ampersand in, that is it pointing to which location in memory. It's like, hey, where is var in my vast memory here? Okay, I want to print that address. Boom, here it is. All right. So you can actually, therefore, because C is so powerful in its more rudimentary levels, you can actually store the addresses or the pointers, if you will, their values. So, for example, you look here, it says int star p. It's a pointer of an int type. All right, and of course you can do it in other ways here too, the formatting. Here's where you can do a multi-line pointer, and of course you can also assign the actual addresses. So, for example, here you have P, C, and C. We're assigning C to 5. PC is to ampersand C. So what it does is it assigns 5 to the value of C. Okay, and then the address of C is then assigned to the PC pointer. All right, so now if you look at this, it breaks down and gives you lots of examples, like changing the value of those pointers, how to work with the pointers. And that's the real strength of C, and the reason why it's still really used, because you can really drill into getting a lot of fine memory control with C, because you can literally just say, hey, here's the address. Here's the address. Here's what the content might be in that address, which is very important sometimes because you need to pull specific values from those registers. All right, and again, something like Java, we never did that because, again, Java, it's like, well, we're not really worrying about that. Now, of course, there are things to kind of worry about when you're obviously dealing with pointers, and that's to update them appropriately. So if you point something to some sort of reference and you don't update those pointers, it can come back to bite you pretty hard. All right. And of course, pointers where they really start to shine is in things like arrays, for example, or in functions. You'll see that they can also be done, or in memory allocation is their other thing they get really pushed into using. Big thing we're going to focus on, though, is that of arrays and functions. So I'm just going to go to the functions here real quick. And, of course, in this example right here, this is a call by reference. And this simply, okay, we got two nums. Address of number 1 and number 2 is passed, so this calls a swap. We're printing those addresses. All right, here's the swap. It says int temp. Temp is equal to the pointer n1. Pointer n1 is equal to pointer 2, and 2 is equal to temp. All right, and so when we run the program, we get 10 and 5 because what were the values? Well, remember originally this was 5, this was 10. All right, so what that does is allows us to update those because that's what the swap does. It updates them via the pointers. And if you think about something like in Java, Java handles a lot of that implicitly for us, so we don't have to handle that. Now, something like C may not have that functionality necessarily all the way built in. So it is something that you kind of have to keep in mind when you're dealing with a language like C, because it's not as high order of a language. It's not object-oriented. It's much more interpreter level. It's more of a mid-level language. So you have to be aware and cognizant of different things such as this when you're dealing with pointers. All right. Or, for example, you look at this other one, it says passing pointers to functions. All right, so if you look here, I have int star PTR, PTR plus plus, so it adds 1 to the pointer. All right, and if you look at the main function, it says we have our P and I is 10. P is then equal to the ampersand I, so it's passing that address. Add 1 to that P. All right, so then it prints it out. All right, remember I was originally 10. It's now going to be at 11. All right, so very important to note how those are being handled because, again, when we're coming from our language with experience with Java, Java handles a lot of that stuff for you. That's why it has the automatic garbage collecting. So C doesn't have that. So it's one of those things that you kind of have to be more cognizant about when you're handling something like C. All right. I'm not going to go over it too much because, again, the examples here break it down really nicely, kind of give you some how-to of the different things. We're not going to worry too much about with the pointers here, just something more you have to be cognizant of as we move through this unit. But I'm just going to go ahead and say we're going to wrap it up right there. And I will see you next time when we get to look at C++.